Okay, we're now going on to Chapter 2, Section 1, and it's called Functions. Now, for some of you, I know, this will be sort of a new area, but functions are a major part of mathematics, actually. And some key words relating to this chapter: the word relation, these are all on our vocabulary list, domain, range, and the word function itself. And coming from Chapter 1 then into Chapter 2, let's look first at the word relation. Well, what I have written under the word relation is an ordered pair, x, y. And you know these items, these numbers, whatever they are related to each other. So for instance, if we were plotting something and our ordered pair was 2, 3, we would go 2 over, up 3, and that dot would be represented by this ordered pair, 2, 3. So the numbers 2 and 3 make up what we call a relation. So the ordered pair is very, very typical of what a relation is. It's numbers that are somehow connected. Now, another key word in this section is the word domain. And if you're reading your textbook, they may make it a little more complicated, but I like to make it easy. Domain, by definition, are the x elements that we have in an ordered pair. So once again, domain refer to the x elements in the ordered pair. And range. What is range? Well, by definition, range is the y element in the ordered pair. So domain and range, in a sense, reflect the ordered pair, which is a relation. And we'll give you some examples as we go on. Now, in the case of function, again, the definition's a little more formal than what I'm going to say, but this is an easy way to remember it. When something is a function, as you look at the relation, the x element, the domain element, is only used once. If that's the case, then something is a function. And you'll see some examples of it right away. Okay, 1 through 4, you're going to put these into their definition. And then number 5 and 6, they're asking, does this relation show a function? And that's true for 6 too. And you see in some cases they could be numbers and letters. Here they're colors and people's names. And we're saying the first element will be the x. The second element would be the y. And as we look at example 5, is the x only paired up with one of the y elements? That is, the x is only used once. So we see a 5 and a y, that's used once. An 8 and an x, that's used once. A 3 and a z, that's used once. A 12 and a w, that's used once. So the x elements are only used once to pair up with a y element. And x is only used once, so this is a function. Now in example 6, again, the first element would be the x, second element the y. This is the domain. Now here we see blue is paired up with someone named Elsie. Brown is Mary and Peter. They have brown eyes. So notice brown is used twice. It's used for M and it's used for P. Green is only used once. So in this particular case, does this relation indicate a function? Well, again, is x only used once? Here, brown, which is sort of our x unit, is used twice. So this is not a function. Okay, here we're talking about a particular box, and that box was matched with its volume. Is this relation a function? Think about it for a moment. You have one box and the volume of that box. And the answer is yes, it is a function. Now another one, we have students with their various classes that they're taking. So again, if it was just a list of students and they're only taking one class, that would be a function. But here it's students taking more than one class. So here you would see a student's name with arrows going to more than one place. So the x element, the student, would be used more than once since they're taking more than one classes. So it is a relation, but not a function. And these are very typical examples that you might find in your quiz and practice. Here they have a series of relations, ordered pairs, and they're asking you to define the domain of these four ordered pairs. So we said, what is domain? Well, domain is the x element. So we write it, and my advice to you is when you write this in your homework log, put the D there. D equals, this is the domain, and you're just going to list them. It's going to be a -3, a -1, a 5, and a 0. And for the range, we're just going to list the y values of our ordered pair. So this would be a 7, a 9, a 0, and if an item is repeated, we only write it once, so we don't write 2 zeros there. And then now we're asked, is this relation a function? Well, going back to our definition, x is only used once. So we have a -3, a -1, a 5, and a 0. Are these repeated? And the answer is no, they're only used once. So this is a function. Now in example 10, again, they want us to define the domain. So we start listing. -1, -3, -9, Now here, -3 is repeated, so we don't list it. And then a 4. And our range is 5, 5, 5, 5, and a -5, so it'll be 5 and a -5. 5, 5, 5, 5, and a -5. If they're repeated, we don't list them. Now, for number 10, we're wondering, is this relation a function? Well, remember, in order for it to be a function, the x is only used once. So we noted here that x was used twice. It's used once there and once there, twice. So this is not a function. Okay, for this, and again, if we had the class where we've gone over some of this because of the possible snow day, we're going to use this for teaching as well. One of the things we want to bring to your attention is what is called function notation. That when you see the letter F and the little x next to it in parentheses, this is what we call function notation. And it often, let me write it over here. They use the phrase input yields output. And often what they're referring to is the little T-charts that we had back in chapter 1, where this would be your x and this is the y. But for the y in this T-chart, when they're referring to functions, it's often f of x. That the function notation can be replaced with the letter y. So, you need to know that this function notation can be replaced with y. And that'll give you some background. You'll see how it works in a moment. Now, for number 11, they gave us this graph. And they're asking us, the first part of it, 11a, is what if the function notation, instead of the letter x here, you're going to have a 1. So, again, let's put this x, this value of 1, right there. Now, if x is 1, that's what they're saying. They want to know the function if x is 1. What will the output be? What will y be? So we look at our graph and we say, well, where is x1? x1 is right here. So we go up. What is y when x is 1? Y is 5. And that's where I get my 5 there. It's a little tricky. Again, without the class, it may be a little challenge. We'll go over some of this, but you want to read your textbook and kind of watch what's going on. That for function notation, that's how they show it. And then they're going to put some value of x there, which is 1. That's right out of our book. And then what will y be? If x is 1, what will y be? Well, on our graph, we look at it. X is 1 here. We go up there, and y is 5. So that's where I get the answer of 5. Now, part B of question 11 is pretty easy. And what they're asking is, what is the domain for this graph? So the domain would be all of the x values. Now, notice in your booklet, they don't put the ordered pairs. I put them there so you could see them. So you're starting here, and you're saying this one is a -3. That's our first one. Then we have a -2, a -1, a 0, a 1, and a 2. And I guess I didn't do this one. This is going to be a 3, 1. And there's our 3. That's this point there. Again, you would have to know how to find the ordered pairs by looking at a graph with these points plotted. And then you're going to pick out the first element. That is your domain. Domain would be the x elements. Now, in letter C, it's a little modification of what they've done for number 1. They're writing this a little differently. They're saying f of x is equal to 2. We don't know what x is. That's what they're asking you. What are the x's where y will be 2? So we go back to our graph, and where is y 2? Well, y is 2 here, so what is that x value? A -3. Y is 2 there, and then y is also 2 here, and that's a 0. So that's where I get these answers from. So once again, this is a little different. They're saying that we have some value of x that we don't know, but the y is going to be, in this case, 2. Y will be 2. We don't know the value of x, so we have to look, where is y a 2? Well, y is a 2 in these two places. What is the value of x in these two places? A -3 and a 0. And that's what they want. And then the last part is a little easy. They want the range of the values on this graph. So what do? Well, you just start listing the ranges. Here's a -4, a -2, a 0, a 2, a 1 in there first, and then a 5. Now notice, if they're repeated, you only write it once. So lots of stuff going on in just this one example. And again, if you want to back up the tape, try it. See if you can come up. Those are the answers. Okay, for example 12, it's actually the same questions, but about this graph. So I didn't write the answers in yet. We're going to do this together, and hopefully you may be able to do some input, but let me lead you through it. Now here we're saying, again, the t-chart, if x is 1, what will y be? Well, we go to our chart. X is 1. And it shows a little bit there. So if x is 1, y is actually 1. So 1 is the answer. And again, I didn't make my graph as carefully as the one in the book, but it's pretty close. Okay, what's the domain now? Well, the domain, if we reflect this point down to here, let me write this, by the way. This is 1, 2, 3, 4, 5. It's going to be negative 3, 5. And this one is going to be 2, comma 0. That's this point. So our range, our domain will be from a negative 3, and negative 3 is in the set, and it goes up to 2, and 2 is in the set. We did a little bit of this in chapter 1. Now, how do we write that in a set builder notation? Well, we're going to say that x is such that negative 3 is less than or equal to x is less than or equal to 2. Set builder notation. So what is the domain of our relation here? It starts at negative 3, and that's included in the set, and it goes to 2, and 2 is included in the set. And by the way, this is called interval notation. But in our book, they want set builder notation. We did some of that in chapter 1. Okay, now for letter C, they're saying that y is 2. So what will our x value be when y is 2? Remember, we don't know our x value. We know the output of this is 2. So what will x be? Well, 2 is right there. So what's our value of x right there? And that point is 0, comma 2. So our value of x is 0. And so this answer is 0. So once again, they're saying that y, we can substitute this for y, equals 2. Well, when y equals 2, what is x? X is 0. And then the last one is, what is our range? And range are y values. So we're going to say y is such that y is what? Well, notice this is our y here. Our y value of this is 0. So it's going to be greater or equal to 0. And it goes up to 5. This is our top value. Let's see how to write that there. Well, I should write it a different way here. So it would start at 0. So y is sort of in the middle here. And then it goes up to or equal to 5. Yeah, that's the way I should have written it. Now, if it had gone up to infinity, then we'd use that other method. So where is y? Y, I should have written it this way. Y is going to be starting at 0 and going up to 5. That would be interval notation for this one. And this is interval notation for that one. whenever there's a limit, we put the letter representing our values in the middle. We'll use one of the other kind in a moment.